Hi, this is another exciting video on graphing functions, and this will be the last one about how to do it with a table. So far we have covered how to graph a linear function, which here's the mother of all linear functions. The previous video, and this is the father of all linear functions, my arms are straight. We've talked about quadratics. Quadratics, that's like a U, like a roller coaster. That's the mother of all quadratics. This is the father of all quadratics. Here, I'll back up a little bit so you can see me. So it's the father, right? It makes like a hill or a valley. Now there's the question of cubics. Well, it's kind of related to linear lines, except my arms will bend a little bit, and that's what a cubic looks like. This is the father of cubics, this is the mother. So this is linear, this is cubic. This is linear, my arms are straight, this is cubic. Okay, so that being said, here we go. Definition and two examples. Cubic function. A cubic function is a function whose term's highest power is 3. So again, I've put this a is not equal to 0. So if a equals 0, look at that equation. Bx squared plus, that's just a quadratic equation. So you have to have that third power there. For it to be a cubic function, there has to be something with a 3 right there. That is huge because in your mind, you're already starting thinking of, is it cubic, is it quadratic, is it linear? That's what should be playing through your mind. Huge, right? Okay, here's some examples. This is the basic, that's the mother of cubic functions. 1/5 x to the third plus 6. Well, this is mother, be a little wider. Remember, like flatter, but really it's wider. And then plus 6 means it's a vertical shift up. Negative 3x to the third means it's the father of cubics. Okay? And if it's a 3, it means it's steeper. So my arms kind of get closer. And then there's this madness that you'll learn how to do when you get to 8th grade when you start graphing a lot more. And that's a normal type of quadratic or cubic function that you'll start graphing and plotting points for. And that does all sorts of cool things. Those look really cool. We'll see how long I take on the first two examples, and maybe I'll show you a couple cool ones that show you how they look. I will be honest with you, these ones are kind of the lame ones, but they're not so lame that they're pretty simple. It's just that they don't have a lot of excitement. The other ones are really cool. These still have a lot of good stuff, don't get me wrong, but I'm just saying, there's some really cool ones. Let's say I asked you to graph 1/8 x to the third, and I want to take a moment. I've already basically filled in the table, so I'll move it up so you copy. That 1/8 right there means I'm going to divide whatever comes out of x to the third. I'm going to divide that thing by 8, not what I'm plugging in. Like if I plug 2 in, or -2, I'm not dividing -2 by 8. I am going to divide -2 to the third power, whatever that equals, I'm going to divide that by 8. So now I'm trying to think ahead a little bit of like, what's going to pop out of this x to the third power? Because I need to divide that by 8. So this goes right along with like the whole divide, choose your inputs wisely. I want something that's going to give me an 8 back, or something that can be divided by 8. So here we go. Of course I did 0. That's my y-intercept. 0 to the third is 0. 1/8 times 0 is 0. So that point is 0, 0. Why did I choose -2? Well, if you look, -2 to the third power is -8. Remember, if it's in parentheses and the exponent is odd, this is all the way back from unit 4, if the exponent is odd, then it will give a negative answer still. And 1/8 times 8, -8, that's just -1. So this is -2, -1. Cool. I plug +2 in, I get +8 back. So it's not like quadratics, where if I square something, I get the same for positive and negative. I don't get the same thing anymore. 3 is an odd power. The rules have changed. So 1/8 times 8 is 1. So this point would be 2, 1. And then of course I chose -4 and +4 because I know -4 is going to be 64. And 64 divided, or sorry, -4 to the third power will be -64. And I know I can divide that by 1/8. Same thing right here. I can divide that by 1/8. So here are my 5 points. Oh, sorry. Here, I'll actually show you the whole graph. So go and if you're having trouble writing down what I showed, this is the amount of work I want you to do. I'm not doing this I'm not going to do this during the video because this isn't what the video is about. It's about graphing it and what it looks like. So that's the amount of work I want to see. I just showed all my steps. I know you can't see at the very bottom. That is an 8 down there. But I showed all my steps. I got my ordered pairs. And that's what I want. I want at least 5 ordered pairs. Can you do more ordered pairs? Absolutely. I encourage you, I implore you, that means beg you, to do more ordered pairs. Do as many as you need to make a good picture. Don't go crazy and do like 50, but if you need 7 or 8 points, do 7 or 8 points. Obviously, if you notice, the points start getting really big. Like if I plug 6 in, 6 to the third power is 216. 216 divided by 8. $20, 21 and 8, that goes into 5 comes down 56. 8 times, no, 7 times 3, 8, 36, sorry, 38. Wait, that's not right. $27. Yeah, 27. Oh, jeez, I can't believe I just blanked on that. It'd be 27, and that's a huge graph, and we don't want to do that. Let's graph our points. Well, I'm looking at my table. I'm like, okay, I got 0, 0. So I'm going to do this with colored pencils, and I really do suggest bringing colored pencils to class, guys. It'll help you out. So there is my 0, 0. -2, 1, 2, down 1 because it's -1. +2, up 1 because that was 2, 1. Oh, so now I make a straight line. Don't do it. Oh, God, don't do it. -4 over -4 down to 8. -8. 1, 2, 3, 4, 5, 6, 7, 8. -8. Now, if I drew a straight line through these 3 points, it's not going to hit this 4th point, so that's why we got to be careful. And there's 4 +8. And this is what my quadratic's kind of going to look like. So let's give it some lines. And by the way, if you in art class you learn, don't do one long line, do a bunch of small lines to make a good line. So wham. Oh yeah. Oh yeah. Because they go on forever. That's a good graph. Yes, that's pretty good. So that's my quadratic. So it does this. This is the quadratic I get, right? So there you go. Epic, right? I think so. Kind of looks like water. So that's our first example. This is the graph y equals 1/8 of x to the third power. Cool. Let's do our next one. This one is -x to the third. That is the father of all linear equation or cubic equations. And +3, so it means it's the father, vertical shift up by 3, because 3 is the constant. I actually did these ones in order. I plugged -3 in, and even with -3, look what happens. -3 to the third power is -27. And negative times a negative, because there's a negative out there, makes +27 plus 3. So I get 30. I only plugged the little tiny -3 in. I got 30 back. These things just blast out these huge numbers, so you gotta be careful and you gotta be ready for it. So for me, I'm thinking I'm probably not gonna graph that point because that is huge. Let's check out the next few points. I plugged in -2. And yeah, I just chose a bunch of numbers near 0. -2 to the third power is -8. -8 and a negative on the outside makes +8. So then we get 11 plus 3. And then what are you going to say? Mr. V, what? Yeah, that should be an 8 right here. And then that should be 14. Good catch. Or 11. And then that should be 11 also. Glad I caught that. So -2, comma, +11. Okay. Plug in -1. -1 to the third is -1. Notice that if it goes in negative, it comes out negative. But this negative makes it positive. And then 1 plus 3 is 4, so we got 4 back. I plugged in 0. I didn't show any work, did I? Mr. V, what the heck? Guys, if I plug 0 in, all that's left is the constant, 3. I don't show much work for intercepts. Intercepts are easy, that's why I love them. This point is at 0, 3. I'll just show off the rest of these. The negative just hangs out, so it turns whatever comes out into its opposite. So that becomes -1, -8, -9. Those are the points we're going to get. Good times. Go ahead and say it. 3 to the third power is 27. Wow, where was my brain at? 27 plus 3 is -24. So -24. Sorry about that. Apologize. 2 errors, you got me. I'm probably not graphing these outside ones. Those are huge. 30 and -24. I'm going to focus on the inner 5. But I did as many points as I possibly could because the more points, the better the picture. And that really is the key to this whole thing. It really is. Here we go. I'll start with -2, 11. -2, positive 11. Oh, use a fancy color. Oh, surprise, that's what it is. -2, positive 11. Oh, I need to label my points. If you didn't do that on the other one, go back and do that. -2, positive 11. -1, positive 4. Okay. 0, 3, that's going to cut right in. Notice how it just, like it sliced in super quick. 1, 3, right? 1, 2. Man, like it's gonna slice in, and then it's just gonna drop like a stone. 2, -5. Like look, it just plummeted. And I'm not gonna put 24 on there. I'm out of space. So this thing is gonna look like this. So, okay, here we go. Cut in, cut out. I feel like that turtle from Finding Nemo. Rock roll in, man. Oh, by the way, 0, 3, positive 2, no, positive 1, and then I got 2 back, and then I plugged in -2, and I got 5, or positive 2, I got -5 back. Please label your points correctly. Do a better job than I did. So that's kind of what it looks like. So these are your basic cubics. This is what we're focusing on for this year. You won't be doing you'll be doing far harder ones in 8th grade. Let's check out some harder ones. Yeah! I'm all for the harder ones. So again, just as this is loading up. Mother of all equations, father of all equations. Okay? And by the way, yes, I do look weird doing it on camera because I'm in the opposite, so please do the opposite of me. This is mother, this is father. Oh man, you guys get confused. I get confused doing it on the video. Let's check this out. Let's plug in a good one. Let's get the view options going. Bigger size. So which one did we just do? We did y equaled -x to the third plus 3. So this is the one we just graphed. Cool. See how it just cut down and then it cut in super quick and then dropped like a rock? Crazy, right? Let's do another one. Y equal. Let's do one that you'll see next year. X to the third plus minus. We'll do -1. X squared. No, we'll do -x. Whoa! What did that just do? Check that out. Oh man, this is where it gets intense. Look at that graph. Like, isn't that so cool? It does this pop up, then it pops back down. So it's got these 2 humps, and it pops back up. This has 3 points that hit the x-axis. Oh man, these are where it gets awesome. And I'm really bummed that I don't teach Algebra 1 when I see graphs like this. Because man, if I end up teaching Algebra 1, I'm gonna love the graphs. Because graphs that's like the coolest part of Algebra 1. It really is. So this stuff is fun, yay. The Algebra 1 stuff, just craziness. So, alright, enough of that madness. There's some basic cubic functions. That's how you do it. It's the same as linear and quadratic. Just the main thing is choose endpoints that'll give you a good graph. I can't stress that enough. Please choose a good input that'll give you a good graph. See you next time.